Hi all. So today I'll be showing you how to cross-compile a loadable kernel module for Linux. So I'll be compiling this module on my x86 processor based Ubuntu machine, which you can see right now on the screen. And I'll be cross-compiling it for a Raspberry Pi 4B, which is an ARM-based SoC. Okay, my Raspberry Pi 4B is running 64-bit Raspberry Pi OS. Okay, so you need to head over to this website, of which the link I'll be putting in the description. Okay, for you. And what you can do is uh, you have to head over to your uh, basically the machine. Whenever you are cross compiling, there is one machine that is quite powerful and it compiles things faster, and then there is one machine on which you just put the copy the uh, whatever products you have built and you run them. So on my Ubuntu machine, uh, I'll have to first install Git, which I've already done. And I'll also have to clone this repository, the Raspberry Pi Linux repository. Okay. Um, you need to make sure that the version of Linux that is running on your uh, Raspberry Pi and the version of Linux that you clone from Raspberry Pi GitHub, that should match. Otherwise the kernel module won't load inside the kernel. Okay, things won't work. So you need to make sure that you can do that using this command that is called uname -r on your Raspberry Pi. Okay, I won't be running it on this machine because it is not required. Okay, so after you clone the Git repository, so I have it already cloned over here on over here. Okay, so we can go to the next step, which is building the Linux kernel. Okay, so let me go to the cross compiling section. So in order to cross compile, you need some other things like Bison, Flex, etc. Make. So you need to just copy this command and paste it in your terminal and install these. I have already installed them, so I won't be running that command. Since I already mentioned that I have a 64-bit kernel, 64-bit Raspberry Pi OS, I'll be copying this command and installing this ARM64 compiler. Okay, and after that, I'll be heading over to this table over here. Again, 64-bit Raspberry Pi 4B. So I'll be copying this command over here, and which I've already done. So you need to do that, and then you have to come down to the build step. Okay, now while building, you need to build everything: image, modules, ttps, everything. But just after this make, you need to also pass a j command, -j, and followed by the number of processors, the number of cores on your processor. So that will speed up the build process. So for example, mm, let us say, so on my machine there are eight cores. So what I'll do is I'll just do a -j8. Okay. And if you don't know the number of cores, what you can do is you can just use backticks with the nproc variable, and that will also suffice. Okay. So that is for building, that is all for building the kernel. After you have built the kernel, what you need to do is you need to have a kernel module, some an example kernel. So I'll be showing you an example kernel module. So this is the read temperature module. I've already made a video on how to read the temperature of the CPU. So the hello.c file just contains that code. Okay, so let me just show you for the sake of completeness. So it is just I have explained how this code works in the video. I'll also give a link to that video in the description. So you need to have a working C code for the module, and then over to the make file. So in the make file, you have to pass this location of where you have built the kernel. Okay. So this command will build a kernel, and uh, it will take some time for you to build a kernel depending on how powerful your computer is. So I have already built the kernel, and uh, over here uh, you need to pass in the uh, location of that Linux directory where you have built the kernel. So for me, it is over here, that is cross compile desktop cross compilation Linux, and that is what I have passed over here. Okay, desktop cross compilation Linux, and uh, followed by the shell pwd, that is present working directory command. And then as you can see, I am building only the modules over here. So this modules is actually the part that we already built over here. But since you are loading an external module, you have to pass in the module argument and build it again. Okay. So after having this make file, you need to, after typing in all this code, you need to save and close the make file. And then in the same directory, you need to open terminal. And what you need to do is, you don't need image and DTBs right now. And modules you have already passed in the make file. So you just need to copy this part of that command. Okay, copy that command and paste it in. Okay, and after that, you just need to hit enter and it will build the module for you. Okay, so as you can see, the kernel object has been created over here. And uh, now what you just need to do is, you need to let us head over here. Okay, so this kernel object you just need to copy to your Raspberry Pi, and do a sudo insmod hello.ko, and that will install the module. Okay, so that's all for this short video on how to cross compile kernel modules. I hope this will help developers, people who are trying to learn Linux kernel in building modules. So that's all, and thank you for watching.